Welcome back, folks. Still looking at this mesh analysis shortcut, mesh by inspection, whatever you want to call it. We want to do mesh and we want to do it quickly. Just like when we had current supplies and we were doing the long, writing out mesh analysis the long way, we've got to treat current supplies a little differently. So we're going to do that in this problem. Again, a problem that we've seen before. Again, a problem that I can go back and we can see that we have an equivalent result, and that's the important part. We want the equivalent result. So the current supply is, oh, it's peeking out right there. That's better. Okay, it's a 2x2 system. We've got two meshes, so we're going to add a matrix here that's 2x2, a vector that's 2x1. So set all that up. Here's the difference. We're going to make our plan. We're going to look at the current supply. We're going to say, I got to write one KCL. Okay, so the KCL is going to go right here, and I'm going to call that the KCL for I2 since that's the only mesh current touching it. I have to have one more equation to fill out this system, and it's going to be a KVL, and it's going to be a KVL around I1. The order, whoops, get rid of that. The order that you put these rows in doesn't matter, okay? It's just how I chose to do it right now. Okay, KCL for I1. Does I1 touch the current supply? No, it doesn't. So it won't be in the equation, right? And since it won't be in the equation, the coefficient is 0. Does I2 touch the current supply? Yes, it does. So it's going to be a 1, and then I just got to pick a sign to go here. Does it flow in the same or the opposite direction? It flows in the opposite direction. So it's negative, and then whatever is labeled here comes down here. And we're done with that one. Not too bad, but you got to have a plan, right? You got to know what equations you're writing in which row. Okay, KVL for I1. Same game that we did in the three previous videos. There were 3 of them. We kind of walked through the same stuff. What does I1 touch that I1 touches? And that's going to be 10. Okay, 4 plus 6. What does I1 share with I2? It shares the 6, so it's going to be negative 6. And then on the right-hand side, any voltage supplies going clockwise, we go up 10 volts, so it's positive 10. And we're done with that. Calculator. Okay, 2x2, 0, negative 1, and 5, 10, negative 6, and 10. We get negative 2 amps and negative 5 amps. Okay. I even introduced something new, and it's only 3 minutes. It's quick. It's really quick, I promise you. And you can do it, and you can do it consistently, and that's why I think it's worth teaching. It's going to make our lectures a little shorter, because we're going to have to do a lot of analysis on circuits as we move on. Okay, I did not queue up this one. Let me go get it. Finding mesh currents with current supplies. Okay, so this one's going to look like this. Something happened to this one, but we can see, even with bad resolution, I do apologize for that, we can see we got the same result. Okay, I'll have to recreate this problem for you. And okay, we can see we got negative 2 amps and negative 5 amps, so we're in good shape there. Okay, so this was again from a previous video. Check it out. The video should still be good. Okay, so that's our simple case with a current supply using the mesh analysis shortcut. We've got to do the same thing. We've got to figure out how to deal with super loops, and they're a little more complicated, but I think you can do it, and I think you can do it consistently. So let's take a look at that. Stay tuned and good luck.